A water bottle is an essential tool for all athletes, not just for cyclists. Proper hydration is critical to athletic performance, and for this reason, athletes are careful about the hygiene and safety of their bottles. Elite, founded 35 years ago and based in Veneto, Italy, is one of the world's leading names in plastic bottle manufacturing. 70% of the human body is made of water, which is the main catalyst for substances that feed and care for an athlete's muscles. It is widely known that 1% decrease in hydration results in a 5% decrease in athletic performance. Every cyclist in the Tour de France consumes about 10 water bottles during each stage. In order to improve competitive performance, pro teams focus on safety, hygiene and ease of use, and for this reason they choose Elite bottles. Elite manufactures bottles in many colors, shapes and sizes for sports, thermal performance and everyday use. All are food grade certified according to international law. The manufacturing process features a state-of-the-art facility with the very latest technology and equipment that guarantees the quality, purity and hygiene of all products. The production process of a high-quality bottle begins with a plastic material called low-density polyethylene that makes the bottle squeezable for a much easier liquid flow, longer lasting and easier to clean and recyclable. The machinery operators use only the highest quality raw materials that are non-toxic, odorless and certified for food contact. The material is moved throughout the facility by pressurized stainless steel pipes and arrives at the transformation area without any contamination. The material moves to the blow molding machine, where the extrusion blow molding process takes place. Extrusion blow molding is the evolution of a process born more than 2,000 years ago, when blown glass was first obtained inside rudimentary molds. These processes have become increasingly industrialized. The last 10 years has seen a steep improvement due to the increased use of digital data for parameters and a new technology used by Elite that avoids the hydropneumatic process in favor of an electrical one, thereby preventing contamination by oil or other agents usually present in production. The final result is a totally pure and hygienic bottle. During the first phase, color dyes, certified for food contact, are added. By using a PLC, a programmable logic controller, the recipe of the bottle is defined, including the percentages of polyethylene and color dye, which are automatically controlled by a gravimetric blender. The high hundredth of a gram accuracy of this device lets us maintain an exact bottle body color throughout the production of multiple batches. The whole process is managed through a next-gen touchscreen PLC that sets and controls all parameters, such as molding and cooling temperatures, cycle time and pressure. Solid material enters the extruder, a specific thermostatically controlled cylinder with a spinning 1-meter worm gear. The material then melts due to the friction generated by the worm gear. Elite uses multiple extruders simultaneously, making it possible to use multiple materials for a single bottle. For instance, it's possible to create a transparent window to check fluid level or to create a multi-layered bottle with an interior surface that is perfectly smooth, while the exterior surface features a soft touch material for an easier grip. Blow molding begins by blowing compressed air into a parison, a tube-like piece of plastic with a hole in one end, so that it inflates until its shape matches the internal walls of the mold. A hot blade then cuts the parison. The object is cooled down, and then the mold is opened to remove the finished bottle. At this point, the machine automatically checks to see if the bottle has been molded correctly. A leak test is performed with a piston compressor placed on the bottle to look for a pressure differential, which would indicate a leak due to dimensional anomalies. The bottle is automatically rejected if any leak is discovered. Samples are regularly selected during production and thoroughly checked to verify all specifications and dimensions such as neck, diameters, thickness, weight and screw thread. Samples are also picked and tested in a vacuum bell to make sure the bottles are airtight and leak-free when in use. The vacuum bell is a glass container in which a water-filled bottle is placed and the air is sucked from around the bottle. If there are no leaks, it's confirmed as airtight, as this process will reveal even the most minor flaws. All molds are made of a high-resistance aluminium alloy that guarantees the perfect production of millions upon millions of pieces. The greatest of care is taken with the surface finishing of the mold to make sure each section of the bottle is polished and doesn't display any visual flaws. Bottles are made of Triton, a new bisphenol-free, shatterproof transparent polyester that has replaced polycarbonate use injection stretch blow molding technology. To have a perfect Triton bottle, the material, due to its high hygroscopicity, must be first warmed and dried. Only then is the material loaded into the extruder to fill the mold and create the so-called preform. The preform is a micro bottle that gets heated to above glass transition temperature so that it expands until it reaches the desired dimension. In the next phase, the preheated preform is automatically placed inside a mold where a calibrated piston is lowered inside the preform until it reaches the desired length. A nozzle then blows air so that the preform adheres completely to the mold, creating the final design of the bottle. A specially designed mechanical arm then picks up the molded bottle by using pressurized micro-suction cups to prevent any scratching. A conveyor belt with mechanical tooling arranges the bottles and moves them to storage. The bottle is then completed by adding the required graphics by silkscreen printing, a process that applies design drawings to the exterior surface of the bottle. A frame contacts the bottle and allows the application of non-toxic dyes to only the areas required by the chosen graphics. Elite graphic designers create all graphics in-house unless they are logos specified by the customer. A video mock-up displaying graphic details of the requested design streamlines the creative development process. Once the design is set, printing films are created, one for each color. These films are then brought to the darkroom to create the frame to be used in the silkscreen printing process. A light-sensitive water-soluble emulsion is applied, which leaves deposits that harden in those areas exterior to the design being created. In areas where color is to be applied, water washes the non-hardened emulsion away. The silkscreen printing machinery is the crown jewel of this department and is managed by computer. And this is how to coordinate and check on the dozens of electrical servo motors that guarantee the quality of all colors, something that can't be achieved by a traditional printing machine. Up to 6 colors can be accurately managed by this process for a photo-like quality to any design. A technician loads bottles into a wide loading tank where a series of automated systems move, clean and place bottles on a conveyor belt to bring them to the silkscreen printing machine. The technician then uses a touchscreen movable panel to control all the silkscreen printing phases, thereby eliminating any manual registration of the frame as had occurred in the past. The technician also sets printing speed, and with quality control carried out thoroughly during the boot-up phase, once the other production steps are optimized, it's possible to arrive at a production speed of 1 bottle per second. An initial flame treatment on the bottle activates the external surface to make the plastic material receptive to creating the necessary chemical bonds that make the color stick. A spatula then pushes the color through the permeable areas of the silkscreen printing frame, applying 1 color at a time. LED lights partially dry everything between the printings of each color. Once the last color is printed, a UV lamp system completes the drying of the area that finishes the color printing. The print quality of every bottle is checked against an extremely precise image of the design by an electronic device. The slightest flaw results in rejection. Bottles are removed from the silkscreen printing machine by a mechanical arm and placed on a conveyor belt that brings them to a large container for storage. The department manager checks the color adhesion of the bottle during both the startup phase and production. The manager does this by making small incisions on the printed area, placing a small strip of transparent duct tape, then tearing it off. The test is passed if no color comes off and there is no duct tape remaining on the bottle. This is how we know that the customer can use the bottle for many years without any damage to the printed areas. Immediately after the silkscreen printing process, the bottles are sent to machinery that wraps them one by one with a transparent plastic film that contracts when heated. This is how every bottle is protected, avoiding damage that might occur during later assembly phases or during transport to stores, and kept clean and hygienic. Meanwhile, another department produces all components of the cap with injection molding machines. Plastic material melts during injection printing. It's injected under high pressure into a sealed mold, which is then opened after the product has cooled down. The cap body that screws onto the bottle is made with polypropylene, a plastic material with a very high mechanical resistance, and a dispenser that will come into contact with the mouth, which is produced from a specifically soft, odorless and taste-free elastomer. Plastic raw materials, always certified as food grade by Italian, European and American authorities, are granular and are loaded into a special tank, fueling state-of-the-art presses, out of which the finished component comes ready for assembly. Many predetermined control and security systems are in place for which the technician chooses product samples to be checked against specifications. The cap is ready for assembly by another department, which also checks for any anomaly in the materials and rejects defective caps. The cap is finally assembled, which is a relatively simple but still very important phase of the production process, since every single cap needs to be checked thoroughly, just as every single item in the bill of materials, which includes both the pre-printed plastic materials and other components such as tags, barcodes, packaging and so on, must be checked. Only then are products ready to be shipped and loaded onto trucks to be delivered to stores worldwide. Elite, design and performance.